Okay, so you're used to the three trig functions, sine, cosine, and tangent, right? So what we have now are three more trig functions. We have cosecant, its abbreviation is CSC. We have secant, and its abbreviation is SEC. And then we have cotangent, and its abbreviation is COT. Okay, now they're boxed together with your SOHCAHTOA sine, cosine, tangent trig functions for a reason. So let's just take a look at the first box. We have sine and we have cosecant. These guys are what we call reciprocal trig functions. So, for example, we know that the sine of some angle is the opposite over the hypotenuse, right? So what that means then is the cosecant of that same angle would be its reciprocal, which would be the hypotenuse over opposite. That's all it means. I'll show you how it works in relationship to a problem. It's really pretty simple. Now cosine, we know, I'm going to try to squeeze that in here, is equal to adjacent over hypotenuse, right? So then secant of the same angle would just be the reciprocal, which is to put the hypotenuse on the top and the adjacent on the bottom. And then we would do the same thing with tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. Now, most kids don't have a problem associating these two together because they kind of sound the same, tangent, cotangent, where these guys sometimes kids will mix up. And the way that I do it is sine begins with an S, so it always gets paired with the C letter. So it's never sine with a secant. You can't have two of the same letter. So it'll be sine with the cosecant, and then cosine. Sorry about that. That's Mrs. Paris calling me. And so then you'll have a C with an S here and a C with an S here. All right, so let's just start, and then it'll make more sense, I think, as we go along. 26 asks you to find the value of sine when you're given cosecant. So that's looking at this first box right here, and we see that they're reciprocal trig functions of each other. So basically the way this works is this. So if I know that the cosecant of theta is -2, technically over 1, right? Then that means that the sine of that same angle should be its reciprocal because they're reciprocal trig functions. So that would be -1/2. And that's it. It's really not that difficult, right? Okay, now I'm just going to show you another way because I know sometimes Mrs. Paris will do it this way. If we know that the sine is the opposite over the hypotenuse, then that means the cosecant should be the hypotenuse of the opposite. So over the opposite. So if you prefer to memorize it this way, using hypotenuse over opposite and then just flip it, you can do that as well. That's up to you. All right, so let's look at 27. That says to find the exact value, I'm going to talk about that in a minute, of the cotangent of 30. So look at the top of your page. I can't see it anymore, but you can. And I know that cotangent goes with tangent. So this is what I usually like to do. I like to start with the trig function that I'm more familiar with, which is tangent. So I say to myself, okay, that would be like asking for the tangent of 30, sort of. And then if you look that up on your 30, 45, 60 chart, you'll see that that value is radical 3 over 3. Now that's what we call an exact value. In other words, I didn't put radical 3 over 3 in my calculator and get a decimal equivalent. An exact value is a fractional value, and we want to leave it like that. Now, the question does not ask you to find the tangent of 30, though. It wants the cotangent of 30. But honestly, it's easier to find the tangent of 30 first, because now all I need to do is say, well, I know that the cotangent of 30 is just the reciprocal. So in other words, take what I have and flip it. It does say with a rational denominator, which means I can't have that radical 3 in the denominator. So I'm going to multiply the top and the bottom by the radical 3 so that I can get rid of it in the denominator, so I can rationalize that denominator. And I will get 3 radical 3 over 3, which will cancel that out. So then finally, my cotangent of 30 degrees will be radical 3. So for 28, it says the terminal side of theta, which is an angle in standard position, intersects the unit circle at, and it gives you an x coordinate here and a y coordinate there. What is the value of secant? Well, let's think about what secant goes with. Secant is the reciprocal trig function, and you can look up at the top of your page there, of cosine, isn't it? And don't we know that cosine, we associate that with the x value? So this really over here, this negative 1/3 is the cosine of theta. So let me write that because it's the x value. So that is a negative 1/3, right? So then if the cosine of theta is negative 1/3, because again, cosine we associate with the x value, then secant, which is cosine's reciprocal trig function, should just be its reciprocal, right? Which is negative 3 over 1, which is choice 1. 29 is a bow tie triangle kind of question. And so if we look at this, it says given that the cosecant is equal to negative radical 10 over 3, and the tangent is less than 0, determine the value of cosine. So let me just pick up a couple of things here. I know I've got cosecant. And if you look at the top of page 15, cosecant goes with sine, right? But what this is saying is that the sine value is negative. It's saying a couple of things. And actually, let's keep going. So we know that the sine value is negative, but we also know that it would be the reciprocal, right? So it would be negative 3 over radical 10. Now I understand that's not rational, but you'll see how that's all going to play out in a minute. And then over here, it says that the tangent of x is less than 0, which means that the tangent is negative. So what you really have is you have an angle where the sine is negative and the tangent is negative. We have to determine what quadrant we're in. So what quadrant would we be in where the sine would be negative and the tangent would be negative? So let's just think back. All students take calculus, right? So all students take calculus, and sine and tangent will be negative in the fourth quadrant. So I'm going to draw myself a triangle in the fourth quadrant, and remember, this is my terminal side right here, and then from that point on the terminal side, I always draw a perpendicular up to the x-axis. All right, now let's go back and let's look at this. So since cosecant and sine are reciprocal trig functions, then what I did was I took my fractional value here and I took its reciprocal. So this is opposite over adjacent. I'm sorry, over hypotenuse. Okay, you could also look at this as this is hypotenuse and this is opposite. So I'm going to find that reference angle, and remember that reference angle is always right here in the corner. And for sine, I have the opposite and I have the hypotenuse. So my opposite is 3 and my hypotenuse is radical 10. Okay, and then what it's asking me to find is the cosine. Now remember that cosine is adjacent over hypotenuse. So here's my reference angle. My adjacent side is right here. I don't know it. And my hypotenuse is radical 10. All right, so that means I need to find that side. So I'm going to call that B. So let's do a squared plus b squared equals c squared, and let's throw the numbers in. So I've got 3 squared plus b squared equals radical 10, that quantity squared. So that's going to give me 9 plus b squared equals 10. which means b squared is going to be 1, which means b is going to be 1. All right, so we want the cosine of x, and we know that that's adjacent. So again, let's go back. Adjacent is b, which I know is 1, over the hypotenuse, which is radical 10. So 1 over radical 10. Now, that's not rational, though. We can't have a radical in the denominator, right? So we're going to multiply both the numerator and the denominator by that radical 10. And we are going to get the cosine of x is equal to radical 10 over 10. Now don't forget, all students take calculus. And in that fourth quadrant, cosine is what's positive, and that's exactly what I have. So then my answer is radical 10 over 10. Tangent here, they tell you is negative, and here they tell you that sine is essentially positive, right? So then the quadrant where sine is positive but tangent is negative is in the second quadrant. So I know that my angle will come around like this, right? From the terminal side, I drop to the x-axis, and I know that my reference angle will always be between that terminal side and the x-axis right there. So tangent, I know, is opposite over adjacent. And that's supposed to be an A, sorry. So I'm going to go from this reference angle, opposite, that's 2, adjacent is 3. Remember, the negative just determines what quadrant you're in, so we never want to have the length of the side of a triangle being negative. So the opposite is 2. Oh my goodness, 2. And the adjacent is 3. And let's see, so we want to find secant and cosecant. Well, I know that secant goes with cosine, right? A C with an S. And cosecant goes with a sine, because a C with an S. And both of those require me to know the hypotenuse, which I do not currently know, so I know I'm going to have to do Pythagorean theorem. All right, so let's do it. 2 squared plus 3 squared equals c squared, and c will be that hypotenuse right there. So that's 4 plus 9 equals c squared. So c squared equals 13, and c is equal to the square root of 13. Okay, so it says determine the value of secant. I personally prefer to find cosine first and flip it. That's just me. You can do that, or you could just do hypotenuse over adjacent. It's just not what works with my brain, but you are more than welcome to do that. All right, so I'm going to find the cosine of A, and I know the cosine is adjacent over hypotenuse, so here I am, adjacent over hypotenuse. So my adjacent is 3, and my hypotenuse is radical 13. Now don't worry about that, because that's not the answer they're asking you for. We want the secant of that, so I'm actually going to just end up taking its reciprocal, right? So then I know that the secant will be the reciprocal of that, which will be radical 13 over 3. So that works out nicely for us, right? But please make sure we are in the second quadrant, and the only thing that's positive in the second quadrant is sine, and I don't have sine in this particular instance. So in that case, I need to take that secant and negate it. Something important that I need for you to understand, that if, for example, in this quadrant, sine is positive, well, its reciprocal trig function will also be positive, which is cosecant. Okay, so in tangent, in the third quadrant, if tangent is positive, its reciprocal trig function will also be positive, which would be cotangent. And the same thing here. if cosine is positive in the fourth quadrant, then secant will also be positive in the fourth quadrant, because I want to show you something. I didn't write it up here, and I really should have, but we know in the second quadrant that cosine is negative, correct? So now if you look at these two, when we take a reciprocal, the only thing that changes is that the numerator becomes the denominator, and the denominator becomes the numerator. The signs remain the same. Okay, so when we're doing all students take calculus, you want to make sure that if sine is positive here, its reciprocal trig function will be positive here as well. The same thing with tangent and cotangent, the same thing with cosine and secant. Okay, this is the first question that we've actually had to come across that issue. All right, so then let's go to the next thing that they ask us to find, which is cosecant. I'm going to do the same thing, so I'm going to find sine first. And I know that sine is opposite over hypotenuse, so my opposite is 2, and my hypotenuse is what? Radical 13, right? Okay, now, in this case, I am in the second quadrant, right here, and sine is positive, so I don't need to change this value. It's not what they're asking for. They're not asking for the sine, but just telling you that it is positive. So then I know its reciprocal trig function, which is what they're asking for, which is the cosecant. Just flip, make the denominator the numerator, and the numerator the denominator. Okay, and that's positive as well. So again, I'm just going to repeat myself. A reciprocal trig function, the sign of your answer should not change. All that should change is the numerator and the denominator get flipped. That's it. All right, so they give us a point -4,6. So I know that that point, -4,6, is going to put me into the second quadrant, -4,6. And I know that this value will be 4 and this value will be 6. There's my terminal side. Here is my angle. And I am going to just say that's my reference angle, shade that a little bit for you. All right, so just a reminder again, -4, I start at the origin, I go to the left 4. This is still a distance of 4, never put the negative there. Then we go up a distance of 6, so that's why that is 6. Remember, we always drop the perpendicular to the x-axis. And actually, let me just put a little right angle there. Okay, so let's read what else they give us. So they say the terminal side of angle x is in standard position and it passes through that point, -4,6. What is the numerical value of the cotangent of x? All right, well, I know that cotangent is the reciprocal function of tangent, and I know that tangent is the opposite over the adjacent. And if I look over at my triangle here, here's my angle, my reference angle, here's my opposite, and there's my adjacent. Haha. So I don't need to find that hypotenuse at all. So I'm going to start by finding the tangent, because that's the way my brain works. Tan x equals the opposite, which is 6, over 4, which is the adjacent. I do know that I'm in the second quadrant, which is the sine quadrant, and I do not have sine, so I should negate my answer. All right, so if you want to, you can do this now, you can do this later, it really doesn't matter, but that's going to reduce to -3 over 2. They want cotangent, so I know cotangent is the reciprocal trig function of tangent, so all I need to do is take that answer and flip it. And there's my answer. Now, if you don't like it that way, again, I think Mrs. Paris might do it this way. This is opposite over adjacent, then that makes this adjacent, oops, over opposite, okay? Totally up to you. But do remember that when you are doing reciprocals, their signs are not going to change. So notice that the tangent value is negative, so is the cotangent value. So in here, the only thing that's positive is sine and its reciprocal trig function, which is cosecant. Right, take a moment and read the question. And as you're reading that question, I am going to draw. All right, so they talk about a circle, right? Oh my goodness, I am not doing too well with circles today. And it has a radius of 6, and the terminal side is in quadrant 3, and it terminates at a point C. So I'm going to start right here, come around into the third quadrant. There's my terminal side, and there's my point C. All right. Okay, so what else do they tell us? I've got a radius of 6. I'm just going to redraw this a little bit if that's okay with you. So my radius, I'm going to take it out of context just to make it look a little bit prettier. So my radius is 6. Here's my reference angle in there. And they say that the y coordinate of point C is -2. So what that tells you is if I'm here at the origin, I'm going over a certain distance, an x distance, and then I'm going down 2. So that means this value right here is a 2, right? So I'm going to put 2 there. And they want the value of secant. Well, I know that secant is the reciprocal trig function for cosine. And cosine is the adjacent over the hypotenuse. So if I look over here, here's my reference angle. So my adjacent is this side, I don't know it, but I do have the hypotenuse. So I'm going to have to do Pythagorean theorem. So what do I have here? I have 2 squared. I'm going to call this b up here. Plus b squared equals 6 squared. So that would be 4 plus b squared equals 36. I'm going to subtract that 4 over, and that is going to give me 32. So b is equal to the square root of 32. And I know that there's a perfect square in there of 16. So then b will equal 4 radical 2. All right, so I am going to find the cosine first, and then I'll take the reciprocal of that. So my cosine is adjacent, and let's go back to this reference angle here. So adjacent is b, which is the 4 radical 2. 4 radical 2 over the hypotenuse, which is 6. And at this point, I am going to just do my all students take calculus. So I have all students, and here I am. I'm in the third quadrant, tangent, and I don't have tangent. So that means I should negate this value. Okay. All right, so now we want secant, which is the reciprocal of cosine. So I am just going to take this secant theta, and I'm going to take its reciprocal, which is 6 over 4 radical 2. And don't forget that I need to have a negative, right? Because reciprocals don't change the sign of the fraction. They just flip the numerator with the denominator, right? All right, well, I can't have a radical in the denominator. So I am going to multiply by radical 2 down here, up here rather, and a radical 2 down there. And that will give me secant theta equals -6 radical 2 over 4 times 2, which is 8. And if I want to simplify that, that would be -3 radical 2 over 4. So that would be your secant value, -3 radical 2 over 4.